Okay. Yeah, I'm back with the same topic, analytical geometry. But then I'm just gonna finish it up because usually what I do is I do one topic like maybe 2 times in a session. So far we have done. Wait. Okay, I was just closing windows because there are some people talking outside. Anyway, like I said, we have done stats, and then now it's analytical geometry. So it means that next week it will be another topic. But then before I start the other topic, what I will do is next week you're gonna write a test. I'm gonna be giving you a test on these things that we were doing. It will be on 2 topics, stats and this analytical geometry. You will write it on Thursday on the same time of our class. So 8:30 up to 9:30 or 10. Yes, that's the time you will be writing a test. So I won't present a lesson on Thursday. I'll just give you a test, and then at the end of that class, you will send me those tests. And yes, I think that's how I will do it. So by the end of the lesson tomorrow, on Thursday next week, it's a test which you will write during the class time, and then by the end of that class time you will send me back the test. Okay. And then again, while I've realized that I should use Sundays more frequently as well, so that we can actually move as quickly as possible. But it's not going to be every Sunday. It will only happen if there was no lesson on Thursday. Like last week we didn't have a class, so I will use these Sundays to catch up. And even for next week, since I won't have a class because you guys will be writing a test, then it means that on Sunday, that's when we'll have a class. Okay. And then another thing is, I would actually like your participation here. I don't know, really like to work with people who won't give me answers. I hope you have calculators with you and some papers to do some calculations, so that we can actually like work together very well. So remember, in analytical geometry, someone was not in the lesson last week or the day that I did this topic. There's nothing new here, and I'm not going to do much details on introduction and explaining a lot of things, because I'm sure you've done it in class. So what I'll do is just to show you how to use this concept when you're answering questions. So as you can see, we have a distance, we have a midpoint, we have a gradient. So these are the main concept of the analytical geometry. So here it means that you use a formula distance to find the distance between the 2 points, and then here you use the midpoint formula to find the midpoint coordinates of a line. And for gradient, we know that we use a gradient formula to find a gradient between 2 points. And another thing with gradient is that these 3 concepts on the right, they are explained by gradient. So this means that if we talk about parallel lines, we have to know that M1 is equals to M2. So it means that if I have 2 lines and they are parallel, the gradient of these 2 lines are the same. So if this gradient was 2, this other gradient as well will also be 2. So gradient lines is gradient, first gradient of the first line is equal to the second gradient of the second line. Parallel lines are explained by gradient. And for perpendicular lines, we know it's the lines which meet at an angle of 90 degrees. So if two lines meet at 90 degrees, then they are perpendicular, and this means that the first gradient multiplied by the second gradient is the product is equal to -1. So this means that we also explain perpendicular lines by gradient. We need to know the first gradient and the second gradient to identify if two lines are perpendicular. So if the question asks you prove that two lines are perpendicular, so it means you must find the first gradient and the second gradient of those two lines, and then if you multiply them and you get an answer of -1, it means the lines are perpendicular. The last thing is the collinear points. So collinear points, it means that we talk about points on the same line. So I have 1 point here, 2 and 3, and they will have their coordinate x, y, and here I will have a coordinate x and y, and I will also have a coordinate here x and y. So to say that these 3 points are collinear, it means that their gradient as well must be the same. So the gradient of this point between these 2 points is equal to the gradient between these 2 points. So also, if you are asked to prove that 2 points or a certain point is collinear or something, then it means that if you know the gradient of these other 2 points, then you can actually determine the gradient of these other 2 points, and if the gradients of this and this is the same, then the points are collinear. So this means that they are on the same line. Okay, so it means that do not confuse collinear and parallel lines. We know that with parallel lines, 2 gradients are the same, but they don't have the points in common. So it means that I can't have a point here which will be equal with the other point over there. But here the gradients are equal between the 2 points. So if these 2 points have the same gradient at these other 2 points, then they are collinear. I hope it makes sense, right? Did you understand what I just said?
Yes.
Okay. So I'm moving on to do the questions in this concept. So we will just be applying everything that we discussed here. So I do not know if you can see this picture, but I'll try and read it for you and highlight important things. So you are given a Cartesian plane here, and with some shape. So we see we have a shape here, and then we can see that this line is parallel to that one. So, and then this line is also parallel to that. So once you see lines parallel to each other, then you must remember that one thing is M1 here and then M2. So this gradient and this ones, they are equal, and the same thing applies here. This line is parallel to that, so M1, or let me say M3, and then M4. So it means the gradient here is the same as the gradient over there. And so let's read what is given. Oh, and another thing to point out, this line here is on the y-axis, and this point here is also on the y-axis. And yes, I think those are the main things that you can point out. So if I read the diagram, they say in the diagram we have point C, which is a point on the y-axis, such that A is this point over there, and then they say is 0 is to 4, and then B point B is over here, they gave us the points, and then point D is also here, they gave us its coordinate, and then they say these 4 points 1 2 3 4 are the vertices of a parallelogram ABCD. So these are the vertices of the parallelogram. Then they say K is the point, they gave us this point 0 is to negative 2 whole number 1 over 4, so that's just the point K. And then L is a point on the line AB such that KL, again we see this KL is parallel to CB. So again it means that this gradient here is 1. I'll call it M5. So it will be equals to M1 and M2. So one thing that you can just write down is just to say, okay, from this diagram, M1 is equals to M2 is equals to M5. And then another thing is you can write that M3 is equals to M4. So you haven't answered the question yet, you are still just pointing out some important information that can be useful in answering the questions. So let's check the first question. The first question says calculate the length of diagonal DB. But if you look here, there is no diagonal here, it's just D over here and then there's B. So it means what you need to do is to construct that diagonal. So you will construct it, you draw.
Can I question, please?
Okay, yes.
If you say construct, never mind.
No, continue, ask. Even if I've done it already or you've seen the answer, just ask.
I've just got the answer.
Okay, no problem. Yeah, so what I'm trying to say is that in order for you to see what is happening, you need to construct. In maths, especially in geometry, you need to learn construction. So as you can see in our diagram, they didn't join BD, it was not joined, but hence they say calculate the length of diagonal. So you can just join these 2 points just to have an idea of, oh, this is the diagonal, and then that's fine. So I'm not going to answer that question. I'm moving on to the next one. I want to show you something. So there's a reason why I say you should join these 2 points. Then the second one says calculate the coordinates of M, the midpoint of BD. So you see, drawing that line will make me to actually find that there's a midpoint somewhere here. So you can basically try to point it out. I do not know if it's on the y-axis or not, I don't know, but I'm just gonna try and point out that midpoint somewhere here. Yeah, this is the midpoint. I'll just label it midpoint M here, capital letter M. Okay, so remember, you first question asked you to calculate distance between the D and B, and the second question it's still asking you to find the midpoint between the same points D and B. And then the third question says calculate the gradient of AD. You have the gradient AD. Where is AD? AD is this line. So you have all the points. You have A, it has x and y axis. You have D, it also have x and y coordinates. So you can actually use the gradient formula to calculate the gradient between the 2 points. Okay, let's move. So now you know the gradient of this line, some value. Now they say prove that AD, that same AD that you calculated above, they say prove that AD is perpendicular to AB. Where is AB? Okay, AB is this line. So once they talk about perpendicular, it means that you must just have something like a 90, because this angle between these two lines is 90 degrees. So you can just have something like that. So it means that now, by knowing the gradient of that other line, you can still use these 2 points to find a gradient of another line. And this means that using the fact that m1 multiplied by m2 is equals to -1, something that I explained on the previous slide. Okay, fifth question says give a reason why parallelogram ABCD is a rectangle. So as you can see, you calculate the gradient, you used that gradient on the second question, and to answer this question you use the answer you found on the previous one. So here you have to know the properties of a rectangle. Once you have a 90 degree here, then it means that if we call this thing a rectangle, it means that, remember, all angles inside a quadrilateral, but this one is a parallelogram. It's a parallelogram because opposite side of these lines are parallel. But parallelogram can be a rectangle, parallelogram can be a square, it can be a rhombus, I think. No, rhombus is a rhombus. But in this case, a parallelogram is a rectangle because of the answer you found it here. So once you have a 90 degrees, all angles, interior angles of a rectangle, each of them is 90 degrees. So the reason is just this one over there. And again, determine the equation of KL in the form of y is equals to mx plus c. So it means this is how you write your answer. Find the value of m, find the value of c. KL is this point here. So you see, writing down this information will help me to know that there's a gradient. Now I know the gradient of this line because it is equals to that one that I calculated. Now I just need to use this point to find the value of c. Okay, moving on to the last question. Write down with reasons the coordinates of c. Right, 3 marks. I'm not going to say anything with this one. So one thing that you need to know is that this topic has like plus minus 18 marks. As you can see, the total, it's one of the topics that you must master. So like in paper 2 of maths, you must master this topic. You must know that if I say I couldn't do it, I must get at least 10 out of 18. That's when you know that at least I tried. Anything less than that, not even 50%. How much is 50%? 18 divided by 2 is 9. 9 is not even close. I can't call 9 as a mastery. So by getting at least 10, it shows that you understand this topic. It's easy. You just need to understand the pattern. So looking at these questions, they go in pattern. You use the answer from the previous one to answer the following question. You don't need to reason too much, but at least understanding that what happens when two lines are perpendicular. And to answer questions like this of saying a shape or any shape on the Cartesian plane, it can be a rectangle, it can be a square, it can be a kite. The answer will also depend on the previous question. It will depend on the previous question. You look at the answer you answered on the previous question and you remember the property which explain the answer that you got from the previous question. It won't be something that will just come out of blue when you are like, okay, uh, when they say prove something is a rectangle, and you just have to talk about something which was not part of these questions over here. The questions of proving usually comes from the previous answer question on this topic. So as long as you just relate that answer with the properties of a rectangle or any shape, then you can actually answer this question. It's just 1 marks, nothing much to think about. And then here, this one also, to be able to answer this, you use the answer from three, answer number three, then you find the value of c and stuff like that. And then for c, for c, c it's a bit long, but it's easy. Um, because here you just have to know that the x value is 0, because this point is on the y-axis, and know the distance from a to c. So knowing that this point is 0, and knowing the distance of this point or of this line, then it will make you to determine the y value of this. Okay, um, let me start answering. Do you want to try this question? So you guys, you will just give me answers. Let me
Can
try.
I say the first one that I did?
Yes, what is the answer for the first one? Oh wow. Okay. The second one, Amara, if you manage to do the first one, then the second one is also easy. I mean, the second one doesn't even
The
have a
second
square
one,
root.
Ebo. So the first one, what I did was, um, standard form, the formula, right? Which is squared into xd minus xb, close brackets, squared, plus open brackets yd minus yb, close brackets, squared. And then x of d is negative 4 minus x of b, which is 4, all squared, plus 2, 2 in, open brackets, 2 minus, and then y cap b is negative 4. And then I said open brackets again, negative 4, and then close brackets squared. And then it gave me negative 8, ne? The first one, the first bracket gave me negative 8. Then the second one gave me 6. And then I square the numbers, ne? And then negative 8 squared is 64. And then 6 squared is 36. And then 64 and 36 will give 100, ne? And then you root 100, which will give you 10. That's how I got it.
With your head. Like, oh, but I
With
get it.
my
Oh, you were writing that down. Oh, okay, without a calculator. Oh, okay. Now I understand. But yes, like even the second one, you can do it without a calculator then.
who me?
Oh,
Okay, okay. Because I think you're doubting me now. Okay. So the second one, um, so you do the same thing, but you you divide by two, ne? So it's xd plus xb over 2. And then there's this colon, like, you know, um, the coordinate sign, the thingy, yeah, coordinates. Yes.
yes, it's a
And then,
semicolon.
yes. And then what? And then you do the same thing again with yd plus yb over 2. Name. King also, I didn't write it down. But anyways, Then you say uy ka d is negative 4, right? And then plus or x ka b. So since ux ka b is it's positive, so it's right, plus 4. So it's going to be negative 4 plus 4 divided by 2 over 2. And then that semicolon, and then for yd will be where's d? No, 2. It will be 2, and then plus y ka b, and y ka b it's negative 4. So what you do is 2 plus into negative 4. And then, okay, let me calculate this. Okay, so it's negative 4 plus 4.
Okay, put your calculator. Just let's check. Here is negative 4 plus 4, which will give you 0, divided by 2, which is 0. And then here you will have 2 plus minus 4. The answer is negative 2 divided by 2, which will give you negative 1. This is the answer for the midpoint of BD. So I'm going to write it as in, this is equals to capital letter M, um, DB. Okay, you left. Welcome back. Anyway,
I really don't know what happened, to be honest.
yeah, no, it's these things of online. They can be like that sometimes. Um,
Yeah, I got 0 is to negative 1.
okay, let's do the third one.
That
Number 3. You have a gradient MAD multiplied by small letter MAB, which is equals to negative 1. Then your MAD is equals to, no, I am actually skipping the question here. Number 3 now. No, we are doing number 3, right? We are finding the gradient of AD. Yes, the gradient of AD MAD is equals to y2 minus y1 over x2 minus x1. My AD is this point, and then there's D, this point. So I just substitute on my formula. Can you substitute for me? That's y2 is 4, y1 is 2, then x2 is 0, then x1 is negative 4, which will be, okay, let me just, so what is the gradient for this line?
1 over 2.
1 over 2. So we found that MAD is equals to 1 over 2. Let's prove this for me then. Number 4. What I'm going to have for number 4? Did you write number 4, Sandiso?
Yes.
Yes, can you please? Oh,
MAB is equal to y2 minus y over x2 minus y.
oh yeah. So it means you must start by finding the gradient of AB, y2 minus y1 over x2 minus x1, which will be AB is here and here. So y1 is minus 4, or y2 is minus 4, my y1 is minus 4, x2 is 4, then x1 is 0. Then what do I get here?
-2.
Negative 2. So by saying that MAD multiplied by MAB, which will be equals to 1 over 2 multiplied by negative 2, and then you get an answer of negative 1. Then you say therefore AD is perpendicular to AB. So this is how you write it. So you first calculate the gradient of the other line, and then you find it, and then from there to prove, it means that you take the gradient of the first gradient and then you multiply it by the answer you found, and then your product has to be negative 1. So if you write negative 1 in this way, then you conclude. Here it's a conclusion. You conclude by saying therefore. You write therefore like with 3 dots like this. This means therefore AD is perpendicular to AB. Okay, that was number 4. So number 5, give reason why parallelogram ABCD is a rectangle. How can you explain this reason? Did you answer this question?
I said that the opposite sides are equal in parallel.
Did you say? Can you repeat that?
The opposite sides are equal in parallel.
Oh, okay, cool. Okay, remember, I said that in order for you to answer, well, your answer is correct, but it can't be, it one of the correct answers. It can be accepted because, but can we accept it? Not really. We didn't prove that this line is equals to that. Okay, we are given that this line is parallel to that, or this line is parallel to that, but we are not sure if this line and this line are equal, or if this line and this line is equal. We didn't do that. So like I said, when you're proving a figure given on the Cartesian plane, your answer must be proven. So in this case, I said that you use the answer you found on the previous question to prove. So you might, it is true that the rectangle have equal sides and the opposite sides are parallel, but we are not sure about this one. But we can at least say that we were told that, or we proved that this line and this line, they are perpendicular. And I said that angles, interior angles in a rectangles, they are all 90 degrees. So if we talk about rectangle, we know that all interior angles, they are each 90 degrees. So to write this, you have to say, you can just say one interior angle is equals to 90 degrees. This is one interior, this is interior, OR is equals to 90 degrees. This, I'm not saying this because I know, or maybe I just feel like saying it. I'm saying this because I proved it from the previous question. So when you answer such questions, you must have proved it. So if you feel like maybe you want to stick with the fact that opposite side of the rectangles um, are equal and parallel, well, one part is true because we are given that opposite side are parallel. But then with the fact that this side and this side are equal, or this side and this, you must do it. It means that you must calculate this side and calculate this other side. And if they are equal, then you can simply say so. You can use this side and use this other side to calculate the distance. And if this distance is equal to that one, then you can simply say that it is a rectangle. But unfortunately, you can't do it because you do not know the point C. So it can't be used, or we can't use the fact that opposite side of a rectangle are equal, but maybe the fact that they are parallel, yes. But you cannot use the parallel lines only, because this is basically a parallelogram. We know that opposite side of a parallelogram are equal, but here use the information that you've already proved, which is this one from above. Hope it makes sense. I'm going to the, okay, wait, before I move. Any question?
Nope.
You also understand with this one, Zanda?
I understand
Okay.
like 90%.
Yes. So
I'm
in
sorry.
general,
I have a question.
oh yes, yes, yes,
All right, so cause y'all we learning this right now.
yes.
For the exam paper, what is coming out? Because in our school we're doing something different, and this is different. So like I'm confused. Like is this like the next section, or like what's happening?
Oh, okay. Wait, I told you that I will help you to catch up with the rest of the class, and with the test that we're gonna write on Thursday, it's gonna have statistics and analytical geometry. Only two topics. That is what will
Oh, so
come.
for the term paper though, is analytical geometry coming out, or
Oh, it will. It will
oh
come
oh
out. Yes. The
oh
one that you are writing at your school.
no, it's a national paper.
Oh, yeah. It's coming. You, you,
I
you're talking about the paper that you write like in November.
in September, yeah.
Yes, because this is one of the topics which are being covered this term. It's covered in this term.
Oh,
So
okay.
it will come up. But
All right.
relax, I will help you catch up. But maybe to confirm that, you can ask your teacher, because maybe it will depend on different schools. I actually don't stay in KZN. I don't know if you are from KZN, but I'm
Yeah, I'm from
not.
KZN.
Yeah, so things are different in regions. I'm in Gauteng and you are in KZN, so papers might have different topics. So
All right.
to make sure that what topics will come, maybe it's best if you ask the teacher at school. What I'm doing here is that to teach you all the topics that I know you will write by the end of the year, November exam. All this will be there. Okay. So, are you fine? Are you satisfied? You don't need to ask any other question?
Yeah, I'm good.
Okay. Ladies, I'm moving on to the next. The next question is to calculate the equation in the form of a straight line, and they gave us the form to write this. So I'm just gonna. Ish, is it not? This can't work. Okay, you guys have answers. Which question is it? Yeah, number 6. The equation KL. Sandy, so I know you wrote this. Zanza didn't write. I don't know. Okay, or maybe you can actually have an idea of how to find the straight line of KL. I can just go back to the diagram. KL, you have a point. Let me just write it. KL, or point K is 0 is 2, negative 2, whole number 1 over 4. And yeah, that's the point K. And then L, I have nothing on L. How do I find the straight line of this? This is not J. It looks like J.
Um,
TikTok. Did you use this or this other one? Um, I can't hear you.
um, you substitute zero.
Okay, I'm actually struggling to hear you a bit, but let me just help you. You know that the gradient of KL is equals to that of AD. Hi, Caesar. And it's equals to 1 over 2. So you know the value of M. And then using this point, you're going to substitute. You say y minus negative 2, 1 over 4 is equals to 1 over 2. X minus 0. Then y minus, or you say plus 2 whole number 1 over 4 is equals to 1 over 2x minus 0. And what is your equation? Which equation did you find?
Uh, for the whole answer or
Yeah, the whole answer, the final answer, the equation directly the equation.
1/2x
Mm-hmm.
minus 9/.
9/4, right? Okay. Caesar, you are late. Like, yeah. But thank you for joining. I just don't know if you're doing this for the register control. Anyway, last question. Like, yo, guys, there's a one question waiting here, and I don't think. Okay, I think we will have time to do 20 minutes. So we want the coordinate of C. Did you do this one, Sandiso?
Tried like
What was okay? What was your coordinate? Just tell me the answer.
um 0
Mm-hmm.
-6.
-6. Do you think your answer is correct? Okay, in math you must be sure of your answer. You have to be 100% sure. You know, like you must be confident with your answer. There's no gut feeling or I'm going with my gut feeling. You must be sure that your answer is correct. So it means that number 7, they say write down with reasons. With reasons. The first thing that you can do, the first thing you say x is equals to 0. Let me write this 0 properly. X is equals to 0, and your reason is because C is on the y axis. That is one of the reasons. And we found the distance here of 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 um of dB, which was 10. So if you look at this line and this line, these are diagonals of a rectangle. Remember, you were told, now you know that you are working with a triangle. I mean, not triangle, but a rectangle. So you are told, you know now that this diagram over here, this diagram over here is a rectangle. You now know because you proved it. So it means there is this diagonal. That is one of the reasons I said it is important to construct. So there's this line that you calculated on the first question, this, which is 10. And this y-axis is also a diagonal of this rectangle. So the diagonal of a rectangles are equal. So this line and this line are equal. So you are using information that you already proved, and knowing that this figure here is a rectangle, now you can apply the properties or the relevant properties for you to answer this question. So this means that A to C, so you know that AC is equals to what? Is equals to dB, which is equals to 10, because you showed, or your reason in this case will be, this is 10. The reason in this case will be that AC and dB are diagonals, because we know that ABCD is a rectangle. So hence, knowing that from here to here is 10, and from here to here from A to this point here is 4, because we know that the y coordinate is 4, so here is 4. So in order for you to get a length of 10, it means you must add this plus this. So how do you do that? You're gonna have, you know that the total AC minus what? This point. Maybe I can just say I'll call it K, because I don't know. You can just call it K, and then you say AK, then it will be equals to KC. You construct, so it means like I just added a point K here just because I just want to make calculations easier. AC is 10, and then AK is 4. No, is it really? No. What am I doing? I'm not doing the right thing. Not doing the right thing here. I said the total length of AC minus this point here, which is 4, is equals to KC. Okay, 10 minus 4 is equals to 6. But then this is the length. So it doesn't mean that here you have 6. No, it is just the distance from here to here, which is 6. But since we want the coordinates of C, then you know that this point is on the negative side of the y-axis, so it means here you will have negative. So this means that your point C, I know that x is 0 and my y point is negative 6. So this means you look in your diagram, and then you remember that this point from here to here is a diagonal, which is also going to be equal in length with the diagonal DB. And once you know the length of this, and you know that at this point you have 4, so it means from here to here it's 4, then you can calculate the distance of from this point to here, which will give you 6. But because we want the y point, we will assign negative, because this length here is below the y coordinate, or it's below the x-axis, so the y values here are negative. So that is how you find the coordinate of C. Anyway, I do not know how long we're gonna have for the other question otherwise. And the first question, which is not part of this diagram, because there's a first question and then there's a second question, so this is followed by this. So all these questions are based on this diagram, but the first one says that you need to show that triangle ABC with vertices A, B, and C is isosceles triangle. So what does that mean? You can see that you do not have a triangle here, like nowhere in this question there is a triangle, so you need to construct it. So 3.1, you construct your triangle, and then you give it the vertices A, B, C, and then to prove that it's an isosceles triangle, what do you need to do if you want to prove that a triangle is an isosceles triangle? Or is this a new word to you guys? I'm sure you've heard this word before somewhere. Even in grade 9, isosceles triangles were dealt with.
You first
Since a isosceles triangle has two equal sides, you first calculate, let's say A, B, and AC are equal. Well, they are equal. And then you have to calculate the distance from A, B, and calculate the distance A and C. And then if they're the same, you also do the same with BC. Calculate the distance with BC just to be on the safe side. If AB and AC are equal, but BC is not equal to AB and AC, then that's an isosceles triangle.
Okay, thank you for answering. That's correct. So you calculate the distances of all the side of the triangles, and if you find that two sides are equal, like here I just marked, I do not know, I'm just trying to indicate that isosceles triangle has two sides which are equal. If two sides of these triangles, after you calculated the distance of them and you find that there are two sides which are equal, then indeed this will be an isosceles triangle. And then second question, which now we are looking into this Cartesian plane, and at least here luckily you do not have to prove it because they're already telling you. They say in the diagram below we have a kite. This is the name of the kite, so this means that they are not going to ask you that prove that this is a kite because they already told you. And then they give you the coordinates, and then they say AD is this one is equals to DC is this point over here, and then they say AB, which is this side, is equals to BC, and then you mark it like that. And they say D is a point such that this is D, is a point such that AD, so AD is this one, AD is parallel to the x-axis. So okay, this means that you can just show this parallel like that. So this line is parallel to the x-axis, and AD, or no, yes, AD is 5 units. So you just write here, you write 5. So this means if this is 5 units, this is also 5 units. And they say CD is perpendicular to the x-axis. CD is this line over here. They say it's perpendicular to the x-axis, so you can just write a little 90 like that. And they say P, or there's a diagonal P here. The diagonals intersected P, so this is a diagonal and this is another diagonal. This is the intersection point. So that's what you do before you answer questions. You read the given information, you try to label it on the diagram. All the information that they're telling you, all the stories that they're telling you on this paragraph, you analyze them and put them in this diagram so that you can actually have an idea of what is happening. So you see here you have the all coordinate x and y. Here there is another coordinate, and then here they didn't give you a coordinate. Here there are no coordinates. They gave you the length of this, but since they said this length is equals to that, so this one will also be 5. And if I knew the length of here, which you might calculate because you know you have all the coordinates, so this means the length of this one will also be equal to the length of that. So if this was 10, then this will also be 10. And then the first question says, well, this is one is not asking you to calculate a distance. It says show that C is 8 is to 0. So by looking here, you can see they said C is on the x-axis. So y value of this coordinate is 0. Y is equals to 0 already. You already know that. But then how are you going to find the x coordinate now? How are you going to show that this x value here is C? How are you going to show that? I'm moving to the second question. Write down the coordinates of P. Another thing, coordinates of P. I do not know if this will be a midpoint or what, but that's how. So basically, you see, of course, this will be a midpoint because this is the intersection point.
Plus, they've already given the coordinates of C.
Yes. So it's easy in this topic. If you fail to answer this one, you can at least try to get this one because you can use this information to answer this one. Brilliant. Okay, the third one, the gradient of BD. The gradient of BD. This is point B, and then this is point D. Oh, but as you can see, you need a point D here. But basically, looking at the fact that this line is perpendicular to x-axis, this and this will have the same x coordinate, but you need to know the y value of this point. Using the fact that this is parallel to that, it means that you can actually find the y value of point D. Let me move on. Calculate the length of the line AC. Well, distance formula, because you know the coordinates, distance formula. The last one, calculate the area of the kite. Can someone tell me the area of the kite? Like, I'm just gonna write down the formula. How do you calculate the area of the kite? Or is this new? Maybe you haven't calculated the area of the kite before. Okay, this is called an investigation. You are going to investigate it. So it means that one thing, you need to find out the area, the formula for the area of the kite, and then from there you calculate the area. And remember, you already know the distance here, and you already know the distance here. So no, the distance here was the gradient. Yeah, damn. Okay, but some of the hint. So this question was short, actually short, but in general, these questions have covered all the concept of analytical geometry and gradient, okay, distance, gradient, and midpoint, and then in gradient line we have parallel lines, we have perpendicular lines, and then we have collinear points. So unfortunately we haven't encountered a question which talks about collinear points. Yes, but if you see it in the test, then yeah, don't be surprised. My handwriting is very weird in this platform, so please bear with me. This is gradient. Yeah, but in general, these are the main concept of analytical geometry. Distance. Wow, is this distance? Distance, gradient, and midpoint. All the questions in analytical geometry will be running around these three things. Calculating distance between the 2 points, finding the gradient between the 2 points, finding the midpoint between 2 points. Parallel lines, if lines are parallel, then their gradients are equal. perpendicular lines. If two lines are perpendicular, then the product of their gradients is equal to -1. Collinear points. If points are collinear, it means they are on the same line. So it means that I'll have a line like this, not necessarily a line, they won't be joined. So I'll have a point 1, then 2, and then 3. And then if I'm asked that prove that this line is collinear, then it means that the gradient of these 2 points must be the same as the gradient of these 2 points. So it means they are, in this case, then they will be said that the points are on the same line. We don't necessarily have a line here, but if the gradient are the same, then we can assume, or we can conclude that these points are on the same line. Because if I have a point here, then I have another point here. If I calculate the gradient between this point and here, I'll get the same gradient compared to calculating a gradient from here to here. So gradient of the between this and this will be the same as any gradient that I'll calculate on the points along this line. So that's what collinear means. Anyway, this is the end of the lesson. Yes, and thank you for attending.